All right, so take two on this. So again, my name is Stephen Bazyl. I'm a developer advocate for Google, working on Google Apps and the Google Apps Marketplace. And part of my job, I work with a lot of developers who are integrating with Google Apps and have to deal with issues of single sign-on and data access using a variety of different protocols. And today we're mostly going to be talking about two protocols, one OpenID and the other OAuth. We'll talk a little bit about some other related protocols as well, but that's going to be the main focus of today. So just quick overview of the agenda, just talk a little bit about why this is important, go into a lot of detail into OpenID and OAuth, again, the related protocols, see how we actually put this into practice when we have an application that we're building ourselves, and then talk about where some of the standards are evolving over the next year or so. So a quick poll, how many people here, just raise your hand, have a username and password that you use to log into multiple websites? Okay, so that's a good chunk. It turns out that, at least in the States, it's about 90% of users actually do this. There's a Carnegie Mellon study on this earlier this year. Related question is, how many people have gone to a website where you've wanted to connect to, say, your Google account or Twitter, Facebook, and it's asked you for, it's asked, give me your username and password. How many people here have actually given that information out to another app? Okay, not as many, so that's better. It's actually still really high. It's about 30 to 40% of people actually do this. So the problem with both of these is, your best possible case is your password is now as strong as the weakest security in any of those apps. The worst case is you could have just given your password out to an attacker. There's actually a really good, how many people here know the comic XKCD? Okay, so there was a really good one a couple of weeks ago on this about password reuse. I have the link at the end, but if you haven't seen it before, I recommend it. It's a really, really funny comment about this particular topic. So, our goal, given that users do a lot of bad things, our goal as developers and our obligation is to make it easy for users to do the right thing and the secure thing. Every time that we build an application that requires a user to have a new account, to have a new username and password, we're making it very difficult for them. Most users probably can't remember more than 5 or 6 passwords. I know I use a lot more than 5 or 6 apps, and by extension, I end up reusing the same account information, and against my better judgment. So when we're building apps, we have to guide users and help them avoid making security mistakes like this. So the first protocol I want to talk to is really about this issue of password reuse and single sign-on, and it's a protocol called OpenID. The OpenID Foundation describes OpenID, as you see here, a safe, faster, and easier way to log into websites. So before we go into OpenID, I just want to talk about this concept of federated identity. So there's this somewhat academic definition, which is this, portable identity across domains without redundant data and administration. What that really means is it's just a way for users to have a single account that they can use to log in to different websites that are managed by different companies and organizations and securely share their identity, but do it in a way that doesn't reveal information about their account and their credentials or password in order to log in. Just 2 things on here. I do want to call out 2 common terms that I'll probably be mentioning quite a bit. One is relying party, or RP. This is basically an application that you would be building. And the other is an identity provider. And this is where a user would actually authenticate and manage their account and their profile and their password. There's a lot of IDPs out there that support OpenID. Google is one, Yahoo, MySpace. Google Apps, every Google Apps domain is actually an OpenID provider. And anyone can actually be one. So a couple key features of OpenID. One is this is an open protocol. It's developed in the open. It's been very well vetted, reviewed for security. It's actually been approved for use in logging into government sites in the US. It is decentralized, so there's no central authority. Right? Anyone who wants to implement OpenID as either a relying party or an identity provider can do so. Right? You don't have to register anywhere. You can just pop up a server and start serving your own identity. You can start accepting logins from any provider without having to go register with them and declare your app. So it's very decentralized, ad hoc, and it's pretty important. We're actually going to get into this in quite a bit of detail later. And the last, it's an extensible protocol. There's already been a few extensions to OpenID to make it easier to do things like get user profile information. So in addition to their identifier, getting their email address, their name, and also some extensions around strong authentication. So requiring that the user authenticated sometime in the last 10 minutes, for example, even if we're doing two-factor authentication. I do want to point out decentralization. This is actually going to be a big part of the talk because that actually has a lot of implications both for usability of OpenID and for security. So why is this safe, faster, and easier? So safe, I mentioned earlier, this is an open protocol. It's been very well vetted, and it has a lot of protections built in there for the user to make sure that their identity is exchanged securely. To the point of password reuse, with those questions at the beginning, when you log in with OpenID, you're never sharing your password. It always stays with the one site that you trust to manage your account information. And because of that, it allows people to use a large number of websites without having this problem of not remembering passwords and being forced to reuse them. It's faster. It's faster for users. My OpenID provider of choice is my Gmail account. I'm logged into Gmail pretty much all the time. And so when I visit a site that supports OpenID, I can log in usually at the click of a button. I don't have to type any account information. I just say, log in with Google, and I'm into the app. For registration, it's a lot faster too, because you can actually get information about the user, things that you would normally ask for on a registration form. And easier. So again, for users, it's just a lot less information to manage. I have a single account. And for developers, this is the important part, it's a lot easier for you building an application because you don't have to worry so much about the implementing account management features. You don't have to implement password resets. You don't have to field support calls for a user who forgot his password and you don't have a really good recovery mechanism. You can actually just offload that all to the identity providers, and you could also take advantage of their innovation in terms of supporting things like two-factor authentication with SMS codes and get that better level of security without having to do the actual development yourself. So let's talk a little bit about how an OpenID request starts. I'm actually going to go into the protocol here. The first thing that you need to do in order to start this is know where the user is authenticating at. And we'll talk about how that UI is in a little bit. But in this case, we're having a user who says, I want to log in and authenticate using my google.com account. When the app gets that request, right, there's this question, right? How do you know how to authenticate somebody given an arbitrary domain name? It could be a domain that you know, but it could be a domain for somebody's server running in their basement or their garage. OpenID has a process called discovery, in which case, given an identifier, you can find out where the authentication endpoint is for that domain, and get some metadata about that provider in terms of which versions of the protocol they support, and so on. And so this is a very simplified view of it. There's actually 4 or 5 different discovery protocols that have evolved over the years. The one that's used probably the most often is a form where the server will return back a simple XML document called an XRD, which is Extensible Resource Descriptor. And it basically just has a bunch of URLs in it. It says, okay, I have an OpenID provider, authenticate the user at this URL, and here's the version and some other features I support. This is something that you'll typically only do once per provider. It's information that doesn't change, and it's information that a lot of the OpenID implementations will cache. But it is important to really understand that this is happening when a request occurs. The next step is a process called association. So in order for OpenID to be secure and for identities to be asserted safely, there's cryptography involved. And in order to negotiate a key, there's this process called association. And actually what it is just a Diffie-Hellman key exchange where an encrypted key is negotiated over the wire. I'm not going to get into the cryptography of it. But again, this is something that is typically only done once per provider and is renewed on a periodic basis. So Once you have this key, it usually lasts for anywhere from a few hours to days to weeks to months, just depending on what the policy is of that particular identity provider. But again, it's something important to know that this is happening underneath the covers when you're using OpenID. So now we know where the OpenID provider is. We know where to send the user to authenticate. We have this key that we've agreed upon between our app and that provider, and we can use that for signing requests. Next thing we have to do is we just redirect the user over to the identity provider. Assuming the user is logged in, maybe they'll get a login prompt with their username and password, whatever they use to log into their account. But before it returns, they might see a screen like this, where they're asked to approve whether or not they want to share their identity with the app. And this is really just a safeguard for users to protect their privacy. If providers didn't prompt the users, it would be very easy for a malicious app to send OpenID requests in hidden iframes, for example, and just ping all the major identity providers to discover where users' accounts are, and actually get some pretty sensitive information about it. So again, you have this little approval process. Assuming the user is okay with it and they trust the application and want to share their details, we redirect back and return an assertion that is cryptographically signed with the key that we negotiated earlier. The content of the assertion, the main point is this ID, right? And this is just a long, opaque URL that uniquely identifies that user. If we've requested stuff using some of the extensions, such as attribute exchange, we can get additional information about that user. And again, this is all signed with a key that is only known between the identity provider and your app. So it's something that you can verify very easily. This ID is really important. This is really what you would use to identify the user. So when that user comes back to your app a couple days later, this is how you would look them up in your database. And you would want to use this instead of the email address for a couple of reasons. So one is, this is what is protected in OpenID. This is what's considered the actual unique identifier of the user. And I'm going to talk a little bit about trust issues, but things like attributes, while they're signed, there's no particular guarantees in the protocol that that information is accurate, and it comes down to whether or not you trust that particular provider. So apps that traditionally have used email addresses as identifiers. This is a little bit of of a change for them, but it's actually a really important point when using OpenID. So I'm going to go back to this issue of discovery. Given that there are potentially millions of ID keys out there, in fact, every Google Apps domain is technically its own identity provider. How do you know how to authenticate the user, right? And you can go anywhere on the web. So let's talk a little bit about the UI of this. So back in the early days of UI of OpenID, the user experience was basically this, right? There was this dialog box or overlay div that people would put up, and it said, enter your OpenID. The problem with this is that the values you had to put in were these long, opaque URLs that users didn't understand what they were, and they weren't going to remember these. So as a result, OpenID didn't get a lot of traction, and it's just not a good user experience. Today, what we see is a UI similar to this, where we're using a mode of OpenID called identity provider-driven discovery or identity selection. So rather than just be this open-ended system, they put up this shortcuts to common identity providers. This is the interface for Tungle, and you can see here you have Facebook and Twitter and Google and a whole bunch of other providers. This makes it really easy for users, but the problem is OpenID had this promise of being this decentralized system where anyone can have their own identity provider. So how exactly do you do this, right? I mean, this is often referred to as the NASCAR UI because it's just overloaded with logos of different providers, and eventually you just run out of space, and you can't represent every provider here. And you can actually see this with Google Apps, where a lot of applications, and again, Tungle being an example here, when you say log in with Google Apps, you actually get prompted for additional information to help discovery happen. And in this case, it's just asking for your domain. So there are some emerging protocols, Webfinger being one of them, which basically creates a personal discovery mechanism that uses an ID people are pretty familiar with, basically email addresses. So I don't know who's familiar with Finger from back in like Unix days. Maybe I'm dating myself here. It's kind of an old protocol. Okay, so a few people. Basically, this is just a modernized version of the Finger protocol, just built on web technologies. But basically, it allows users to type in a very familiar identity and then use that to find out where their preferred identity provider is. Just a much better experience. There are a few apps out there that do UIs like this, but at this point, it's still a pretty young protocol and not widely adopted. So I want to go back to this issue of trust. Earlier, I mentioned using that identifier instead of the email as a primary key for looking up users. So the reason for this is that the protocol itself has very, very strong guarantees in there for making sure that providers can't spoof each other's users, right? So there's a Google provider can't assert user identities on Yahoo or MySpace or any other system. Likewise, a Yahoo provider can't assert a Google identity, right? And an attacker who has his own little server in his garage can only assert IDs on the domains that he controls. So you know that identity that you're getting back is relatively safe to use, assuming that you have a good client library, of course. The bad news is that when you get extension data, names and addresses, there are no guarantees in the protocol, and a provider can really return any information it wants about personal details of the user, like their name and email address. So for some applications that really need to have strong assurance on the value of an email address and whether or not it's verified and truly belongs to that user, what you can do is actually create a whitelist of trusted providers. So you know that Google is going to do the right thing, Yahoo is going to do the right thing, and LinkedIn, and so on. In those cases, if you get a response back, you can say, I will trust this value on face. If you get somebody logging into a provider that you've never heard of before, and you have no relationship and no knowledge about them, then you would want to fall back on kind of traditional techniques for verifying information. So send a confirmation email that requires them to click through and prove that they own that address. So that's OpenID. So I want to switch gears a little bit to Oauth, which is a related protocol, but really addresses a different problem. So OpenID addressed that first question, right? How do you prevent people from reusing passwords? Oauth is more about how do you delegate access to your information and access to your account to a third party without sharing your password. So before we go in, there's a few terms I want to go over that are really useful to understand. And there's really four concepts at play here. One is the protected resource, which is just the data that you want to protect and that you want to give access to for a third party. This could be my mail, it could be my calendar, it could be contacts in my address book, photos on Flickr, anything like that. The resource owner is the person who is authorized to share that information with a third party and make that decision. It's often the user, but not always the case. The server is just the server that serves the API and enforces the access control. And the client is the application, or in this case, the third-party application that wants access to that information. So there's three basic steps in using OAuth. The first is a step of client registration, where you have to establish basically a shared secret with the service provider. And it's basically just establishing a username and a password for your application so that you can authenticate. Step two is getting access to the resource. And there's two variations we're going to talk about, one called two-legged OAuth and another called three-legged OAuth. We'll get into a lot more detail in just a bit. And then the third step is accessing the resource. And you do this by basically doing a signature on the request and including that in an authorization header that has an OAuth realm in it. And there's actually two different types. More common is just to use HMAC, but you actually can do public key cryptography if the provider supports it. So for step one, this registration step is kind of a manual process. It's something that's different for every provider out there. For Google, we have a console that you can go to and basically claim ownership of domains. And as part of that, get a key and a secret for your application to use, or upload a public certificate if that's the way you want to go. If you're on a different provider, there are different URLs. Here's Twitter and Foursquare, for example. And so every provider that's OAuth enabled is going to have a slightly different way of doing this, but they're all basically asking for the same information. It's just identifying yourself as a developer, setting up your credentials, and then you're good to go. So on the access control grant, there's really two cases you have to worry about here. So most of the cases, if you're building a consumer-facing application, it's most likely the case that the user is also the person who owns the data, right? So if I log in and I'm for Tungle and I want to share my calendar, I'm sharing my personal calendar, right? That I'm authorized to share. If it's a business that's using that application, it's very often the case that individual users don't actually have permission to share company data outside the organization. For Google, for example, we have a corporate policy that we're just not allowed to share information outside. In that case, the person who's authorized to do the access grant is not the user itself, but somebody else in the organization. So depending on which case it is, you're going to use one of two different methods for authorizing, right? So in the consumer case, you use this redirect-based mode called three-legged OAuth, and this is probably what most people are familiar with if they've ever used an application that uses OAuth. In the case of an enterprise or business applications, it's a little bit more common to see two-legged OAuth. And again, we'll get into a little bit more detail of how both of these work in just a bit. Before we go into three-legged OAuth, I just want to show you an example of an OAuth authorization header. Generally pretty simple. The main part is the signature itself. There's also some other identifying information in there for identifying the version of the protocol, which application or which client that's identified by the consumer key. And then two other things I just want to call out are the nonce and the timestamp. And these are just cryptographic techniques to basically, one, introduce some randomness into the request, and two, to basically timestamp it so that it will have an expiration. If we don't do this, if we don't have these fields, nothing would prevent an attacker from replaying this request. But by having the randomness and by having a timestamp that makes it a short-lived signature, we have some added protection against people that are actually sniffing the wire and trying to intercept requests. So let's talk about three-legged OAuth. This is the version of OAuth that is probably the most confusing for developers. And the reason is that you have this concept of a token in three-legged OAuth, but there's three of them, right? And when you use each one changes depending on which part of the actual authorization step you're involved in. The good news is that the one that you really care about is the last one, the access token. That's the one that you're going to save in your database. That's the one that's going to be your long-lived authorization for that user. The other two are really just temporary tokens that you use during what's called the three-legged OAuth dance. And let's take a look at how that works. So the first thing that you do as an application developer is you need to go get a request token. You can really just think of this as it's a session identifier. It's just a way to correlate the next couple of requests. But at the end of this whole process, you're just going to discard this. So it's not something that you really need to worry about, but you just for the next 3 or 4 screens and your 10 lines of code, it plays an important role. So anyway, we go, we make a server-to-server call, we get this token, and now we can redirect the user to that particular service provider's authorization endpoint. And when they do that, users will often see a screen like this. So this is Google's verification screen. And you can actually see the different concepts that we introduced earlier represented here. So you can see the resource owner in this case is the user that's logged in the upper right. The client that's requesting access is represented there for the user to see. And the resources, in this case, calendar and contacts, that's the information that application wants to access. And so we have all this information. The user can then make a decision as to whether or not they want to proceed. And assuming they do, they're redirected back to your application. This time, the response contains a different form of the token called the authorized request token. Again, this is not something that you really care about on a long-term basis. Really, what happens is as soon as you get this response back, you're just going to go and call the server again and say, here's this authorized token. Give me back an access token. And when you get that access token, this is really what you wanted to get to. Like, this is basically the credentials you're going to use whenever you're signing requests for that user. And this is what you would stash in your database for that user. Two-legged OAuth is a bit different. So that whole sequence of steps that I just showed you don't actually apply in two-legged OAuth. The reason is that the user who's accessing the application isn't entitled to actually do that authorization. So there's no point in having them go through that process. So when you do that, there's actually a different authorization process that I'll show you in just a sec. The one thing I do want to note that even though we don't have a specific token for a user, we actually can still make requests on their behalf. And in the Google APIs, this is done by just appending a query parameter to any request that we can basically just put the email address of the user and say, we want, I want to access, for me, it's sbazyl@google.com, my personal, set of data, even though the authorization was done by my domain administrator. So it'll make a little bit more sense when you see this screen here, which is how access management is done. And this is actually just a screenshot from the Google Apps control panel. So this is what your IT administrator would see and how they would grant access to an application using two-legged OAuth. And here you can see the resource owner, which is the administrator. You can see the client on the left and the resources listed on the right. So when this access grant is done, right, that application now has permission to access all the data for that domain for all of the users. And this is where that OAuth requester ID comes into play, where even though I have access for the whole domain, there are cases where the particular data is still tied to an individual user. And a good example would be an email account or a calendar. Right? You want to get a specific user's calendar, and that's when you would use the OAuth requester ID. There are APIs that are not user-specific and some data that's not user-specific, in which case you would just omit that data and access it as just the application acting on its behalf, on its own behalf. So there's a couple other protocols that I want to mention. And these are, probably something, who here has used like GData, any of the Google APIs? Anyone? Okay, so just a handful. If you go through the documentation at code.google.com, you're going to see two authentication protocols mentioned quite a bit. And they deserve at least some recognition. One is client login. This is a very old protocol that was proprietary to our APIs. It's basically just a really simple improvement over HTTP basic authentication, where instead of sending the username and password on every request, you just exchange it for a token at the beginning and then send that token. And so it minimizes the exposure of the username and password when sent over the wire. But it still requires that the application know the username and password of the user that's trying to use the service. Authsub is conceptually very similar to OAuth, but it's just a Google proprietary protocol that was done before OAuth was an open standard. They're so similar, in fact, that a lot of our OAuth error messages actually reference Authsub in the error text. And that's more of just a bad error message on our behalf, but it does demonstrate the fact that these are actually very, very similar concepts. The point of just mentioning these is these are legacy protocols, and if you're developing new code using any of the Google APIs, don't use these. That's the short of it. These really, OAuth is the way to go. Right now it's OAuth 1.0. There's a new version of OAuth being developed called OAuth 2 that we'll talk about in just a bit. But basically, we want to support the open standards, and we encourage people using the APIs to use the standard way of authenticating and delegating, and not these legacy proprietary methods. There is one other protocol worth mentioning here, which is there's actually a hybrid mode for doing OpenID and OAuth. So if you go back and look at those two flows, right, you'll actually notice that the user experience for both of them is very similar, right? There's a step where the user has to authorize sharing data, sharing their identity, or they have to authorize sharing their data. And if you're an application that's using both OpenID and OAuth, you have a user experience problem, right? So the user signs up, they sign up with OpenID. The first thing they see is this prompt that says, do you want to share your identity? They click yes. 2 seconds later, they get this next prompt that says, do you want to share your calendar? So there's actually an extension that lets you piggyback the three-legged OAuth request for authorized request token inside an OpenID logon. And the reason for doing this is basically just to avoid that case of having the user acknowledge that they trust your app twice. What the user sees is really just a combined authorization screen. In this case, you can see, again, the client identified, the resources, and in this case, both the identity of the user that they're sharing and also a representation that they're the owner of the contact data in this case. It's actually a really simple protocol to use. The extension is basically adding 2 query parameters into your OpenID request. And then once you're done, you end up with an authorized request token that you can immediately exchange. And that whole three-legged OAuth dance is just eliminated. This is a really useful technique if you're doing a new user registration, right? And you want to register them and let them sign up using their OpenID identity. But it also happens to be that they're signing in with a provider that you also want to get data from. Not every provider you're going to want to do OAuth with. Most providers will just ignore the request for authorization. But if you know that you're going to Google or Yahoo and you want to get contacts or calendar data in the process, it's a really great technique to speed up registration for users. So let's talk about how we would actually put this all into practice. So I'm going to start with a really simple application. This is my registration form. I asked for an email address, name, password confirmation field, and my login box is really straightforward. So I have username and password, and my database entry or my database table is pretty trivial here. Just same information you saw in the registration form. Obviously, this is pretty much simplified versus we'd have a lot more information usually, but this is what we're going to assume as our starting point. So I have an application. Let's say it's a CRM app, right? Customer relationship management. We sell it to small businesses, and it's doing well, right? So I got a bunch of customers. Those customers start giving me some feedback about my app, and they say, this is a really great product, but I have all this contact data in Google Apps, and it would be great if I can sync my contacts in my CRM tool with the contacts I have in apps, so that I can share docs and email them and do all these great things. So we said, okay, let's actually use these APIs and we'll do OAuth. So we add this link to our account page. It says, hey, click here to share with Google Contacts and Calendar and whatever APIs that we want to add. When we click this is when we would start that three-legged OAuth dance. So we would get the request token, redirect the user over to approve it, come back, get the access token, and then we can start using those APIs. In our database, we have to make a small modification, and we add this new table that says, okay, let's store OAuth tokens. So we're storing the token and the secret for each of those tokens. Also the provider. This is just a nice little technique that if we want to start supporting other APIs in the future, so we want to add Twitter integration, Facebook integration, and get social data about our customers, we can do that. And we can store, store all the access tokens for all these different services out on the web. So once we get our access token, we stick it in the database, create a new row, tie it to the user, and we're good to go. The next thing is, customers say, "Hey, this is great, but I have too many accounts to remember, and I don't like reusing my passwords. Can't you just use my Google login or Yahoo login, whichever provider you want?" So you said, "Okay, great. We'll do OpenID." And so now we have, we go and we modify our UI and we add our little, miniature NASCAR UI to give them some provider selection. So now user can click that and sign in or sign up with OpenID. And in our database, now we have to store some additional information about those users. So we add a federated ID table, and basically it just gives us a way to store that opaque identifier we get back from OpenID. And also when that user comes back, now we can actually have an easy way to look up that value in the database and find the correct user. So far so good. We've used OAuth, three-legged OAuth. We've used OpenID. if if it was a user who was new to our application and signing up with OpenID, we would want to use the hybrid mode. And generally, you'd only use that for new users. Users who've already logged in, generally, you're already going to have your OAuth token, and there's no reason to actually do the hybrid mode. So it's kind of a special case, but it is handy to simplify things. So our application is doing great. We have happy customers. We have OAuth and data sharing. We gave them a simple way to log in with OpenID. Then we hear about this thing called the Google Apps Marketplace, which since I work on the product, I have to pitch. It's a really cool place for business-to-business software. And Oauth has done a little bit different in that case. Because it is a business-to-business store, authorization is typically done by the domain administrators when they purchase the application. And so they get this, during the installation process, they get a screen like this that says, hey, you've agreed to the terms of service. Now you need to grant access to this app so it can access information. Do you want to approve? And it's just a way that the domain administrator can do the OAuth approval for all their users up front, so that when it's time for an individual user to go in and access the application, they don't see any of these prompts, right? They just click a link in Mail, and they're logged into the application. Their data's already there. Things just magically work. So to do this, we need to start using two-legged OAuth. And so we just store a little bit of extra information here to say, hey, this user is associated with the domain. It has two-legged OAuth enabled. And what this allows the application to do is, when you're writing your OAuth code, is you can just check and say, well, if this is a customer we got from Google Apps and they have two-legged OAuth, use that. If it's an individual consumer user that just authorized individually, we'll use our three-legged OAuth token. And so you have to do a little bit of code, switching in there, but for the most part, it's an additional 2 or 3 lines of code anytime that you want to use OAuth. So pretty simple. And in this case, we actually ended up using all the different variations in our application because of the way it evolved. So we started with username and password, added three-legged OAuth, added OpenID, added hybrid for signing up new users, and then when we got into the marketplace, started using two-legged OAuth. And it's very possible, and there's actually quite a few apps that go exactly through this evolution and end up supporting a wide variety of these protocols in their application. So just to recap on when to use each of these, three-legged OAuth is great when you have an individual user that they own their own data and you just want to get access to it. Two-legged is more for the business case, great for Google Apps. OpenID for getting a user's identity or to log them in, basically. Hybrid when you want to do sign up a new user and get access to data at the same time. And again, client login and also just please don't use them anymore. So let's talk about a little bit about where things are going. First one I want to mention is OAuth 2. This is a new version of OAuth that is being standardized under IETF. It was based on a protocol called Oauth Wrap that I think was originally done by Microsoft and a few others. But basically the whole community's come together to standardize this. There's a couple features that I want to point out. One is probably the most notable is this concept of bearer tokens. Basically, a bearer token is a value that you would include in the request, but it doesn't require cryptography. It doesn't require actually signing any information about the request. The reason this is useful is for a couple of cases. You can think of a web mashup where you actually want to start doing API access in JavaScript in the client. Right? That's not an environment where cryptography is easy, and it's also not an environment where you would necessarily want to put cryptographic information into a client app. The same holds true if you're doing any sort of like IT administration and scripting and using curl. Right? You're just trying to do command line access. Pretty hard to do cryptography in curl or in Bash or Perl or anything like that. So bearer tokens are basically short-lived tokens that you can just get constantly refresh and get new ones. But they allow you to actually put these in use OAuth in environments where the signature processing is difficult to do. It does generally require the use of SSL in order to maintain security, but that's these days really not much of an issue. The other one is better support for different environments. So the initial OAuth spec basically tried to take all the different clients that use OAuth and treat them the same. And so whether or not it was a web app or a desktop app or a command line script or a mobile app, it just assumed that the protocol would work in all those cases and it'd work great. It turned out that wasn't the case, and that each of these different environments has particular needs for how users interface with it. So one thing that the new OAuth spec does is explicitly address each of these different use cases and call out how exactly OAuth is used in each of these. And so there's much less ambiguity in the specification and much better support for environments like mobile apps. Yeah, so this is a pretty new protocol. It still is in development, but there are actually providers using it. Facebook uses it, LinkedIn, a few others. And it's definitely the way OAuth is evolving and being done on a pretty rapid basis. I don't know when Google APIs are going to support it, but I would expect sometime next year. The other is a much earlier stage protocol than OAuth 2, which is this protocol called OpenID Connect. So if you go back and you look at how OpenID works and how OAuth work, they're actually really similar protocols, right? You start with this one step of exchanging key information, right? In OpenID, it's done on a very ad hoc basis during that associate step. For OAuth, it's done via a developer console for that provider. But in the end, you're actually exchanging the same information. You're identifying your application and getting credentials for it. They both involve redirects, right? They both involve an authorization step where the user has to confirm that request. And in a lot of cases, and you see this with the existence of that hybrid extension that I mentioned earlier, that there's a lot of cases where apps just want to do both of these. So why not just make it easier? And so OpenID Connect is an attempt to do that, and it basically rewrites the OpenID protocol on top of OAuth 2. And it's actually such a simple spec that the entire OpenID Connect specification is about 1 page. That's how easy it is. At this point, there's nobody implementing this. It's really just an idea that's been floated around by one of the original authors of OpenID, and I think he's actually a Facebook engineer. And it's actually something Facebook did with Facebook Connect, which is since rebranded. But basically, using OAuth as a way to exchange identity information. Twitter does something very similar. So very, very early stage at this point, but something that I would keep an eye on because it's very likely that this will gain momentum in the next few months. So a couple tips before we finish. If you are going to implement any of these, and I certainly encourage people to do it, it does make life a lot easier for users and a lot safer. The first one is, the protocols and the cryptography behind it can be challenging to implement correctly. The libraries that implement them that are out there are really easy to use. In a lot of cases, adding OpenID is 10 lines of code or so, depending on your application. Similarly for OAuth, it's really not much more than a few lines of code just to initialize a client library that supports OAuth. So just don't try to implement these yourselves. I actually did run into a developer last week that implemented their own OAuth library, and let's just say it didn't go well. I also saw somebody do an OpenID library that had just riddled with security holes. So just use the open source libraries, and there's a ton out there, pretty much in every language, and some commercial products that make it really easy to. The next point is to protect your OAuth secrets. This is true for the access tokens you get in three-legged OAuth. You should treat these as username and password. If you were, say, connecting to a database or a mail server, any system that you would be storing credentials for, you would want to treat these access tokens the same way. And this is really true for two-legged OAuth because the scope of the authorization on with your two-legged OAuth credentials is so much bigger. So with an access token, it's tied to an individual user. For two-legged OAuth, your authorization is for an entire set of users. And it could be a company of one user, it could be a company of 500, 1,000, it could be 100,000 student university. So treat these like sensitive cryptographic materials and keys and protect them appropriately. Again, don't write your own libraries. And then two things. One, on user experience. It's really important to help users do the right thing. If we make it difficult for them, if we make them, have to remember lots of information, if we make them surrender their username and password or reuse it, they're going to get themselves in trouble, and they're going to start, getting careless about who they share their password with, who they trust. And then if we saw with the original OpenID implementation that where they didn't think about user experience, if you make this hard for users to do, they're just not going to use it. They're not going to use your app, or they're going to do something stupid and give you their bank account username and password, which actually people do. So if you make it easy, make it obvious to do the right thing and the secure thing, users will be a lot better off. And likewise, trust. In these cases, you are asking users to share details about themselves. With OpenID, it's their identity. With OAuth, they're sharing their data. And this could be very personal data, information about their friends and families. The reputation of your app is important, and it helps users feel a lot more comfortable about going through these authorization processes. A couple of resources. If you just want to learn about OpenID and OAuth, you can go and actually just read the specs there. We also have some additional information on code.google.com. If you want to play around with three-legged OAuth, there's this really nice utility called the Oauth Playground that lets you actually jump through all those different stages of the three-legged OAuth dance just in JavaScript. And you can actually see what the actual raw requests and responses are at each stage in that process. It's a really handy tool. And the XKCD comic I mentioned earlier is up there, 792. It's pretty funny. So definitely check it out if you haven't seen it before. So on that note, I do want to thank everyone for attending. This is the last session of the day. There is a meet and greet outside, but before we do that, there is just a closing session over in the main hall where they did the Android talks. On that note, I'll happily take questions, and then if not, head over to the other hall. We'll wrap up and then have lots of drinks and food. Thanks.